So, do you want to make some introduction or not?
Yeah, I can do.
Yeah.
So first of all, welcome everybody to the Accenture office. I'm James Eardley, and I've probably spoken to some of you on email. This is the first meetup I've been to in Bratislava. I went to one when I was in London in February, and it was cool. There were various kind of presenters and then some beers and kind of pizzas at the end. So I think the next one we do, we'll perhaps do some beers and pizza.
Yeah.
But yeah, for me, my role here, I've been with Accenture 10 years. As you probably guessed, I'm not Slovakian, I'm English. My wife is Slovakian. I moved here 3 years ago. Since I've been here, I lead DevOps. So I run the regional DevOps and also globally for the Microsoft DevOps. So we have a team of about 15 people in Bratislava, a further 10 people in Bucharest, and then a team in India and the Philippines. We're seeing a big demand in DevOps, as you all will know. Predominantly the tooling we're using is either kind of on the open source side, kind of Jenkins, kind of the usuals, predominantly open source, and then on Microsoft side, the SDS, linked to Azure or on-premise TFS. And what we're finding we're doing at the moment is pretty much working with clients throughout Europe on some of their, transformations. So there's quite a lot of diverse work, and I invited a number of the teams to come along as well just to say hi. So that's it. And don't mention football, please. I'm still in mourning for England.
Okay, perfect. Thank you very much. So, yeah. So my name is Frantisek Ferencik. Maybe you know me, some of you. This is Meetup format, so you registered, most of you, for a Meetup. It's 5th one. So name of the Meetup is DevOps Slovensko, Slovakia. So it should be related to this topic. Maybe some of you attended some previous sessions. Maybe some of you. 1, 2, yeah, 3 guys, 4 guys. Okay, so I would like to, that was an idea to maybe go into the hands-on a little bit more. One company or some guys just contacted me regarding scenarios, Kubernetes stuff. You read it on the description of the event. That it's Katacoda. Yeah, so maybe you know it. So I would like to go through those scenarios, and of course you can see that there is a VMware there on the left down corner of the screen. So I am from VMware side. I'm trainer of VMware technologies, and recently, maybe for 1 year, we have a lot of open source activities, open source projects in various levels. So my plan into the future is also to deliver VMware courses, which are going into the area of Kubernetes, primarily via networking part of infrastructure. So that will be maybe most interesting part of the content. And also we will have the lab. A lot of labs, but we don't have time for all of them, of course. And I think we will not finish one of those. Yeah, so we will see. So expectations should be like first part to deliver some kind of theory and context, and then we should go for labs from the perspective of Kubernetes itself, constructs inside of Kubernetes, and then also some kind of networking stack connected for Kubernetes for a platform, complete platform. which is a VMware solution. Yeah, so let's say, composed presentation from slides I already delivered. I think it was on the 3rd meetup. And also I have some stuff which is more into the networking of Kubernetes. So yeah, those use cases when we are trying to go also from perspective of VMware solutions are application repackaging, cloud native new kind of microservice based solutions. So we have approach for simple scenarios when we have pure Docker image kind of approach of developers, and as there is a improvement inside of company or inside of the organization or inside of the team of people, they are going to be more mature, then we are going higher to the stack of as a service, container as a service, platform as a service, or function as a service, which is the latest development also inside of company of VMware where there are a lot of activities in the field of function as a service, which is of course using containers, containerized Kubernetes architecture. So there could be a lot of scenarios, situations when we would like to, let's say, use other tools. Yeah. Most of those things are using as an infrastructure behind the scenes hypervisor. Yeah. So it's a combination of hypervisor, which is more infrastructure level, providing resources for nodes of Kubernetes. And then we have, of course, some kind of networking tools around it, and but basically we are using hypervisor. And I will talk about the networking solutions, which is useful and usable for multiple hypervisors, not only VMware. Yeah. So now we are talking about solution, which foundation of that solution is open source. Originally it was open source, and now it's fully compatible across the hypervisors, and again as an infrastructure under the node of Kubernetes. So when there is a situation at the customer side or development team, when there is a pure container runtime, container image, of course we can handle it like we can run Docker host on top of the hypervisor. We can run it as an unmanaged instance of Docker host from which we are running images for a runtime, or it could be managed, integrated solution. So of course, I'm from VMware world, so there is kind of full integration of pure Docker runtime host, Docker host, running and integrated on top of the hypervisor, in this case ASXi hypervisor. So that's something which is maybe usable in more simpler infrastructure, or when there is a preference to use Docker as an approach for development of applications. Then potentially there could be maybe some kind of demand for automation for larger scale. Yeah. So then we are going into the higher levels. We should, of course, we are going into the situation when we need transparency for a monitoring. We need some kind of automation or integration with log system. We need then also on higher level some kind of scheduler. Yeah. So we have scheduling in the platform or of managing of containers. We have orchestration, for example, on an IaaS infrastructure as a service also behind the scenes down there under the Kubernetes. Yeah, so this, of course, is applicable all across the vendors or solutions on the market. I'm specifically here and talking about some parallels into the VMware world. Yeah, so if you know vSphere, if you know NSX-T hypervisor, yeah, so that could be IaaS, but it's not, of course, required. And I will talk about the multi-platform, multi-hypervisor approach when IaaS is not exactly required to be NSX-T vSphere VMware. Yeah, so potentially, of course, it could be Red Hat stuff. It could be KVM, hypervisor for networking, which I will talk about, and it could be also OpenShift, yeah, potentially. Also, when we have portation directly into the OpenShift. But again, of course, I'm from VMware world, so that's my first choice because I know that platform. But we are porting with a networking solution, which I will talk about, into the Kubernetes deployment of other vendors also, as I mentioned, OpenShift, platform as a service. And platform as a service, or let's say some kind of application level, when we are not anymore talking about container runtime image, we are even not talking about the containerization or orchestration, container orchestration platform as a Kubernetes, scheduling, but we are talking about native interface for application code level. Yeah, when we are submitting code into the platform as a service, when that platform is creating all structures, including networking, including load balancing, including routing, including all logging, monitoring, and deployment of some kind of prepared services in one black box platform as a service. Then we have something which is not here maybe. Of course, everything is as a service, so we can potentially have nowadays something like function as a service. Yeah, so that's of course something which we know. From VMware perspective, those implementations are somehow cold. So there is cooperation between VMware and its own fork, which was formed in 2011, which is called Pivotal. Yeah, Pivotal is known for a platform as a service cloud Foundry project, which is open source. But originally, guys, in Pivotal, they are a fork of VMware, which just divided from a root VMware company into the new company, yeah, which is Pivotal. So then we have a collaboration for some time already, for maybe 2 years, when there is a platform to run Kubernetes on-premise or off-premise. But primarily we are approaching, or we are positioning this platform for on-premise at your place to run complete infrastructure for, let's say, well-behaved, expectable Kubernetes infrastructure to have a nice behaving Kubernetes running on your enterprise level infrastructure or customer production system. Yeah. So day one, day two, deployment, operations, troubleshooting, networking. Of course, a huge part is networking. We are going to talk about networking today. Yeah. So then, of course, this Pivotal Container Service is about the level when we are providing Kubernetes cluster for consumer. Yeah. So we are on that level of or infrastructure layers. When we have a lot of layers, so we are in a layer of providing Kubernetes for a consumption for developer. So developer then is going to consume via kubectl constructs, namespaces, and services, ingress, whatever constructs we have in a Kubernetes. So, and on this platform as a service, which I talked about, then we are talking about Pivotal Cloud Foundry open source project, or Pivotal named, branded, supported Cloud Foundry. Because Cloud Foundry is delivered by a lot of guys, IBM or Atos or some other guys. There are a lot of implementations, and some vendors, some companies are providing Cloud Foundry platform as a service. Yeah, so there are a lot of constructs inside of that platform as a service. You can then consume on-premise or off-premise. There is a Pivotal service where you can demand, you can try instantly and run your code, directly your code in an infrastructure when the platform as a service is providing you, for example, some website, completed running state. Yeah, so okay, I will just jump this because there is, maybe it's not working here. Okay. So there is an important thing is that when we are going into this direction, we are talking about do it on yourself or do it yourself. So you have basic construct of Docker, and you can nicely play with that and use some local image registry connected somehow to securely store container images, scan the Docker images, and deploy images somehow, manually, in your way. How you would like to have Docker, it's your choice. You can run it on physical, of course, but primarily it's very attractive to run it somehow on the higher level, on some kind of hypervisor, yeah. Or you are going into some kind of higher constructs, as I mentioned, Kubernetes application. So that's. By the way, this is the new name. Pivotal Application Service it was named Pivotal Cloud Foundry, PCF. Yeah. So the Pivotal is completely renaming now. Well-known names for 6 years, 7 years, well-known, now renamed. Yeah, because there is a wider strategy now. So Pivotal Application Service is PCF. Yeah. And then we have PFS, which is function service. Yeah, so serverless functions now, which could be, of course, run in the state in cooperation with Pivotal, but of course you can run your own deployments or implementation. I will mention one open source project. One guy which was in Bratislava 2 months ago is open source senior guy in VMware now. VMware acquired this guy, and it's open function as a service project. Maybe you know it. Yeah, so it's open sourced function as a service, which now is a little bit more integrated into some other parts, for example, Kubernetes and monitoring and stuff like that. Yeah, so I picked from the complete solution of container service, VMware Pivotal Container Service, which is, by the way, completely downloadable. You can download it, you can run it. If you have some evaluation of VMware ASXi hypervisor, you can download complete set of those structures to have complete Kubernetes production-ready environment. Yeah, so there are components like VMware. It's not maybe so interesting. What is interesting here is that we are running some networking part, which is called NSX. From its VMware construct, and then we have multiple Kubernetes clusters. Yeah. Thing is that there is very strong component of Pivotal of Cloud Foundry, which is called Bosch, and that's primarily more or less agent taking care about health of Kubernetes cluster. Yeah, from a perspective of node, Kubernetes node. So when there is a problem with one of those nodes, master or worker, it will just take care about that node. So there is something similar, like we have pods inside of the Kubernetes. When Kubernetes is taking care about pod, so checking against the declaration that there should be some number of pods running, and if not, it will initiate and start to have compliant state against declaration. So then we have something similar, but on the level of nodes. So then we need some stuff which is taking care about Kubernetes health. And that stuff is called BOSH. And BOSH is, I think, open source now. It's open source, which is, let's say, a little bit tuned version of Borg. So guys working on Borg in Google went away into the Pivotal, that time when Pivotal started, I think it was the 2011, when they split from VMware and they a little bit tune it, and that's like play with letters. So it's like Bosch on steroids, let's say. So Bosch, like we have Borg +1+1. It's like just a code name they chose. Yeah. So it's trick in the name, Borg +1+1. So in the alphabet, when you have R, there is +1 is S and G +1 is H. So that's like a stupid thing. Okay, so what is there that we would like to have expectable state of infrastructure of Kubernetes? So we would like to have solid deployment and prepared also for fast deployment, but also for day 2 operations, for troubleshooting, for scalability, upgrades of Kubernetes cluster. Yeah, so that's something which is very important, and we have Borg on steroids, so Bosch for Kubernetes health scalability upgrade, for example, when you are upgrading Kubernetes versions. So then you have again something similar as we have in pod level inside of Kubernetes, but now we have it one layer lower for all complete Kubernetes cluster. When we are going to upgrade Kubernetes cluster, you can have version, rolling upgrade version, when you have one version and trying to go for another version as a parallel version. When you have some kind of time for testing, and when it's okay, you are going for the next upgraded version. So, and of course, there are a lot of stories about this. So you can deploy it on-premise, you can deploy it at a cloud provider, service provider in Slovakia, in Czech Republic, Hungary. We have example already in Czech Republic when guys there are deploying Kubernetes clusters in kind of multi-tenant architecture. So there are structures when cloud provider will have tool which is pure multi-tenant tool for multiple customers, and then there will be integration of all this magic stuff to deploy this magic stuff for every specific customer by cloud provider. Of course, we have already complete solutions, kind of complete solutions from Amazon, from Google, from I don't know, Azure. Microsoft is quite active also. Yeah. So they have implementations. They are doing a lot of stuff in containerization. I'm pretty sure you are aware of that. And of course, VMware have also container service as a solution which is consumable instantly. And by the way, we have HOL hands-on lab for that. So if some of you would like to test, some other stuff as I will, propose, you can test. You can, go for that, and primarily we can use also nice stuff from as a service. So I think Amazon they have Kubernetes service. Yeah, so VMware has also everyone has KS or KS Kubernetes service. Yeah, so all right. So what I would like to cover, maybe I will just not start with this one, but I will start with a different one. Yeah, well, okay, so all right, so I will just briefly touch, and maybe we can discuss on this. Of course, we had session of one guy. I don't know if he's here, but last time I think it was we had networking, Kubernetes networking. It was quite deep dive. So I will just touch those things regarding Kubernetes from a perspective of basic constructs and then networking, because that's something which is demanding, quite demanding, and I will try to handle. So, okay, we know that we would like to use some kind of architecture which is scalable, which is useful for fast deployment, rolling upgrades. So we know this. Yeah. So primarily we are using container runtime. So we have Kubernetes Master. We have structure of master and worker nodes when we have agents of each node. And of course, there is a smallest structure manageable, which is called pod. Yeah, so that's something we are trying to handle, run, restart, reschedule, and stuff like that. Kube scheduler is something which is replaceable by a third or some projects, some kind of other schedulers from third parties, but generally we are using that one which is out of the box of the mainstream release of Kubernetes. So this is basic structure. We have master, we have multiple nodes, and master is kind of important structure which is taking care about desired state. Of course, it will be also important for a solution, networking solution. I will talk about later. I will talk about networking solution, which is, I would say, very nice from a perspective of security, from a perspective of services like load balancing and automation in those areas. And then we need some kind of, let's say, communication from master to third party. So third party could be any kind of solution, but we will focus on networking. For us, it will be, of course, very important. And then, of course, nodes and all deployment could be potentially on physical node. In our approach, it will be completely running as virtual machines. Yeah. So master and nodes, Kubernetes nodes, those machines would be virtual machines. Yeah. Which is nice because you can play a lot with virtual machines. It's much nicer from the operational perspective to have virtual machine because of a lot of benefits we have with virtual machine. Of course, but if you would like to have some kind of crazy performance or some other requirement to have it on physical, you can do it, of course. But from the flexibility point of view, it's pretty damn better to have it virtual machine to then play with it. Do a lot of stuff with the Kubernetes cluster. So then we have namespace. Namespace could be on multiple layers. It could be construct or approach inside of networking stack. But primarily in Kubernetes, we use this as a kind of, let's say, multiple or kind of multi-tenancy inside of the cluster of Kubernetes cluster. So we can then divide it across the multiple teams. We can apply some kind of quotas. We can apply some kind of policies. Yeah? So we can kind of use it as a multi-tenant approach. I will talk about this from a little bit wider perspective because from the networking, especially in the networking field, we need some kind of real, let's say, separation. We need some kind of policy application per group, per application group, per, some parameters, and that will be quite important for us. This will be very, very important for a networking approach I will talk about later. So, of course, yeah, we are using labels. Label is important for, let's say, concept of branding or creating groups of services when you can combine, in various types of situation when you need to combine application and to do some structure, some operation with pods. You are using labels, so that's very powerful and most important construct for a kind of handling multiple pods into the logical structure. When you have kind of application, 3-layer or multiple layer application, you would like to have it as a multiple groups. So those are labels then used. And by the way, labels or tags are used also in infrastructure as a service. VMware is also using tags. In VMware is called tag. So we can then tag all structures, virtual machines, and use that as some kind of parameter for third-party system to do some procedure against those marked objects. And also, tagging or labeling is used in the networking infrastructure. Yeah, so software-defined networking. I will talk about software-defined networking today. It's using also those labels from Kubernetes, and also it can use tags from hypervisor infrastructure. Yeah, so, and then we have kind of definition, declaration, how the service should look like. Yeah, how many pods should be there, and what will be networking construct there to access pod or pods from external infrastructure. So what we will touch in the first part of labs, then we will have those basic structures of Kubernetes, including multiple ways of networking we have inside of Kubernetes. On other side, second part of that lab, I hope we will go through all of those. There will be integration software-defined networking for Kubernetes, which is called NSX-T. Yeah. So what's going on there? So basically, we had all discussions regarding multiple ways how you're providing or how communication is going on there inside of Kubernetes. What we would like to then provide is communication which is going out of that infrastructure to the client or to some kind of application which is a virtual machine out there or physical system, simply access from internet or from some outside infrastructure. So there are constructs and communications which are inside of pod, yeah, which is primarily one IP address when you have multiple containers, Docker or some other runtime which is used for Kubernetes, communicating out of that pod via IP address. So that's one thing, and of course we have kind of communication inside of Kubernetes across the pods. So when we have one node of Kubernetes, it's let's say quite simple structure when it can handle it, let's say easily. When we have multiple nodes, we have let's say some options. So I will show you one thing which is complementary for this, and it's something which is called Illustrated Guide to Kubernetes Networking. Yeah, so I have this nice overview of Kubernetes networking from the official Linus Torvalds organization, where they have trainings for Kubernetes, and there is a reference for this. This is a document from Tim Hocking, which is Google architect, yeah, for Kubernetes. So so there is a kind of communication when you have multiple nodes, and there is a MAC address with physical IP address, or let's say if it's virtual machine, doesn't matter, but it's kind of communication when you have multiple IP addresses. So and then of course you have some L2 connectivity switch, which is virtual switch or physical switch. Pretty much doesn't matter, because if in virtualization you have L2 simple switching, when you have pure virtualization platform, when you have software-defined networking, then we have additional functionalities. I will talk about those later. So there is a communication, across those nodes. When you have standard communication of node, which is trying to contact some other node via IRP. So IRP is service of operating system, or let's say system, which is on the network, which is taking care about communication when there is communication to IP address, and there is no entry in a local ARP table. So it's for a first time communicating against some IP address. So then, if there is no communication from history, it has to go for a broadcast. Address which is FFF, which is reserved on network every time to broadcast. And then it will just look for that IP address. If IP address is there, responding, and local system will just store that entry. Yeah, so that, okay, I was looking for 192.168.1.2. I didn't have MAC address, but now I received a response. So I have that entry that, okay, MAC address 10.23.45 is mapped to a specific IP address. Yeah, so if it was, in this time, it was the communication against the 192.168.1.3, so node C, and communication was there. So, from that moment, it's not necessary to broadcast anymore, of course. Yeah? If there is a communication first time, IRP is stored locally, and it's not required anymore to go via broadcast to flood all the network anymore. So then it's going to direct communication to the specific node. Yeah? So, I mean, this is quite obvious communication, which is well known. Standard way of communication in normal network. When you have some constructs inside, which is in this Kubernetes world, it's pod. So then we need to handle it somehow. Yeah, so we need to map IP addresses. When you have local pod IP address, because I mentioned that the pod have one IP address and you have multiple containers inside of pod, but still with one IP address going out to the world. Right? But those pods are running in a host on a worker, Kubernetes worker, which is, as previous slide was, there was a 192.68.1.1, for example, as a node A. Yeah, so there should be some mechanism to forward and communicate to outside world. Yeah, so well, there is some kind of call. If it is inside of node, it's not a problem because it's holding tables, RP tables, segments, information about network is held inside of the node. It's not a problem. When there is a kind of communication outside, it's going to broadcast again because there is no information about the specific address, and yeah, there is an RP response from that node. Yeah, in this case, there is a response that okay, this segment is there. To handle this, there is a mechanism, and we have multiple implementations. How to provide this magic, yeah? Because if you will study Kubernetes in a official courseware like Linux organization of Linus Torvalds, for example, of course it could be anyone, but they are CNCF, member. There is a CNCF cooperation officially with Linux organization of Linus Torvalds about certifications now for Kubernetes deployments. So I would say they should be okay with theoretical part of Kubernetes. Of course, Google is there as a founder of open source project Kubernetes, but you have statement there that you need, or Kubernetes is expecting that there will be some network connection, yeah? So that's something you have to create, you have to provide for a Kubernetes. So this magic thing could be done via some kind of solutions. You have multiple projects for networking on a Kubernetes IO page. So of course, we know some open source solutions, and I will little bit compare those solutions or name or describe those solutions and compare them to NSX implementation. Yeah. So all this magic stuff again has to be provided, has to be made somehow. One of those options, how to do it, could be overlay, for example. Yeah? So overlay is foundation of software-defined networking. We are using overlay already for some time in non-containerized world. Non-Kubernetes world, we have overlay, which is doing a lot of magic stuff for classic virtual machines. But we are using the concept of overlay also for Kubernetes networking to connect Kubernetes nodes across in one side, for example, on premise, but also to connect potentially remote sites. Yeah. So okay. So this is something you have to do, or you have to create some structure to provide informations like where is segment 10.03x 24/24 class, on which node, physical node, or which Kubernetes node this one is. So then if you know and you can traverse information that this one is on a node 1, so you need some kind of controller. You need some kind of structure which is providing this. It could be controller, it could be also distributed way, so simply some kind of structure to provide this information all across the nodes. So we need complete network L2 map for all nodes to be able to communicate across the pods, across nodes in the Kubernetes. Yeah. So I mentioned controllers. So for example, NSX has, as SDN, software-defined networking, has controller, set of controllers. They're running somewhere and learning and providing L2 and L3, of course, routing table, routing information, yeah, across all of those nodes. And of course, providing then connectivity also outside, to outside structures, because sometimes we need dynamic routing. We need BGP, for example, implementation to go with routing in dynamic way into the higher level for other systems potentially. Yeah, so this is exactly what we are doing with software-defined networking then. Yeah, so we have communication from 10.0.1.2, which is on one node, to 10.0.3.2 on other node, yeah, via some physical address, which is IP address or interface of node. Yeah, so L3, so we need, of course, some kind of communication point, some kind of gateway for that, which could be virtual appliance, for example, and that's the thing. Now, if we have some network component there, we should, deploy it somehow. We should take care about that. We should take care about availability of that gateway. Yeah, so, and we need dynamic routing, and we need a lot of stuff. We need load balancing, then as another component. So a lot of stuff there. Yeah, so yeah, this is of course some kind of routing there. Of course, we need some kind of routing information where to go. It could be, of course, you can do it statically if you have small infrastructure. Yeah, so you can type simply a few routes there across the nodes, and you are done. Or solution could do it like that. Or you can have a BGP or some other structures or protocols for dynamic routing. Yeah. Yeah. So then, if you have dynamic routing, you can have more nodes dynamically deployed, and you have dynamically added all of those routing tables via BGP, which is the protocol for dynamic routing. OSPF is there also, or ISIS, but BGP is well known, and we have also some other. In NSX-T, there is other implementation which is called Genève, for overlay, but that's not routing, but it's overlay layer which is used there. But generally, BGP is supported all across the solutions, networking solutions. Yeah, so yeah, here we have some kind of overlay, which is additional construct there to take care about you know, all those structures, but it's not required now to go into that. Okay, so Flannel, we will have some kind of comparison because Flannel is well known, and we have this deployment also with some other project, which is called Calico for policy management, and then we will a little bit compare this implementation, which is well known and spread across the deployments, with solution which we have. So, yeah, generally, when we are talking about overlay, which is the Flannel solution, primarily what is important there is that we are creating like pipe or tunnel across the physical network when you know, it brings benefits because it's not necessary to play on a physical layer of network. You can create just simply endpoints on the nodes on network, and all segmenting or security stuff is applied in the pipe, so like tunnel. Yeah, so maybe I will talk about it later with NSX, but it's quite nice way how you can dynamically create structures on network without touching physical network. Yeah, that's the magic of overlay, which is Flannel, for example. So, because then you can play completely with networking constructs, security and segmentation on the level of solution, overlay software solution. That's the magic stuff. That's the magic thing you can do. It's not required then to go to physical layer and to create manually VLAN to have kind of security with access list on Cisco switch or Juniper or I don't know, it doesn't matter. Yeah. So that's the thing that you are creating, or you are on node, physical node, virtual node. Primarily in VMware, it's hypervisor level. When we have physical network card, and we are creating so-called VM kernel port, and from there you are connecting to other VM kernel port of other hypervisors. Yeah, and all security stuff is managed in a tunnel of those two connected. Yeah, so basic connectivity then on physical layer, and you know, you are minimal requirements on physical layer on simply L2 connectivity, L2 L3 connectivity between those hosts, and then from that moment you are completely controlling security on network from the hypervisor or from some solution. Yeah, because VMware has complete solution, so VMware is providing also end-to-end. So you can have completely integrated L3, L4 load balancing, all micro controlling, micro segmentation, security stuff, all integrated. Yeah, but okay, that's a little bit another story because it's integrated then in a hypervisor. Yeah, so overlay, yeah, could be hard part, could be hard way. Thing is that we have implementation which is nice, which is well documented and integrated into the Kubernetes, but not only to the Kubernetes. We can use platform of NSX then for other stuff also. So it could be hard. It could be hard, but with a solution which we are talking about here, okay, it should be much nicer. It should be much more convenient to use overlay, which is nice, fascinating way of doing security, separation. But another way to have it, somehow expectable. Yeah. So okay, what we are talking about is connection between Kubernetes world and legacy world. So of course we need some heterogeneous connectivity across the new system, cloud native and existing system. Yeah. So when we will talk about this plugin, in the Kubernetes we use CNI for networking. CNI is a standard, open source Kubernetes IO. When you will check, there is a CNI network interface standard format, which is provided to third parties to implement, to connect, to provide some value for Kubernetes. In this area, it's about networking, of course. So we have also storage interface, Kubernetes storage interface, which is for third party to provide storage resources for persistent storage. But in this, we are talking about CNI network interface, which is in the implementation of NSX called NCP. Yeah, doesn't matter. So CNI container network interface is again Kubernetes naming. Yeah. So Weave network or Calico and Flannel, those are CNI plugins. Cisco has some plugin, So yeah. So what we have. That's interesting. Okay. So what we have here is a plugin which is going to configure networking for Kubernetes, and which is consuming some IP, let's say, settings, yeah, for a Kubernetes structure. So yeah, generally what's going on there is that NS6 there, which is called NS6 Manager there, is going to listen for Kubernetes API server, which is master. API server is on master, and is like listener. So when there will be some structure instantiation of namespace in our case, it will automatically create network segment for that namespace. This is the really important part. Yeah. So again, when there will be namespace or pod, but basically we are there is namespace is created. It will listen, it will track, and it will create automatically construct for the namespace. So it will then automatically create some structure which is taking care about security, about load balancing, about security. Yeah, out of the box, nothing to do, just create namespace. That's it. And you have completely visible, let's say, monitorable, transferable way of deploying a complete set of functions on network, including security and stuff like that. Yeah. So what we are using there behind the scenes, those are so-called switches, logical switches. Yeah, that's the construct there. Of course, it will take about routing. It will take about nothing, potentially firewalling and some kind of, let's say, analytics or security introspection or checking mechanism of what's going on there inside of the application or on the network. Yeah, so complete security applied and visible and manageable. Yeah, that's important. So the topology there is then like you have default namespace, you have kubesystem, you have then new namespace. You are creating namespaces inside of the Kubernetes, and every each namespace will create by default virtualized so-called edge device. Yeah? So it will be then visible on the level of hypervisor. This solution is completely, or completely, not completely, but it is visible inside of the infrastructure as a service, as an object, as a virtual machine, which is a networking, firewall, router device, taking care about communication of specific namespace where you have multiple pods in the one namespace as a construct inside of the Kubernetes, which is, let's call it like multi-tenant or tenant construct. Yeah? So we have support for dynamic routing there, east-west, north-south routing, and that's of course important because then we have it implemented like high performance inside of the kernel of hypervisor. North-south is implementation when you have communication out to the physical world, when you are thinking about routing, dynamic routing out. Yeah. So yeah, this is maybe not so interesting, but behind the scenes we have Kubernetes nodes, yeah, and multiple pods on each node. And this solution, yeah, as I said, is there are deployed virtual machines, edges, router firewalls, and then we have on the level of hypervisor we have logical ports connected, and we have then implementation inside of the hypervisor when we have multiple VLANs per one port implementation for segmentation, but it's inside of the node of the virtual machine, which is a Kubernetes node. Maybe it's better to see it in the lab environment. This node VM in reality is simply virtual machine. Yeah. So this is virtual machine running on hypervisor when you have segmentation of pods, communications inside of the connect, which is one connect of virtual interface of virtual machine, which is in fact Kubernetes node. Yeah. So and then of course there is some kind of management, there is some kind of CNI plugin interaction. So when there is Kubernetes, consumer is instantiating new namespace. So of course there is created policy and some kind of segmentation and new edge. Yeah. So and you can see that hypervisor here. Yeah. So hypervisor, which is the node physical server where you have hypervisor installed. Yeah, and you have multiple Kubernetes nodes running there. It could be NSX-T VMware, yeah, but it could be also KVM. Yeah, so we have for this stuff NSX-T software-defined networking. It's supported to run NSX-T hypervisor on one side, but you can run it at KVM also. So what's there, and it's quite important, that we are using structures like open standard OVS there. Yeah, so OVS, Open vSwitch, is there used inside of the Kubernetes node for applications of security there inside for namespaces, for pods. And yeah, all that solution is using OpenSwitch also on a KVM. So if you have KVM implementation via OVS, Open vSwitch, you can fully manage it from one solution, NSX-T solution. Okay, I mean, this is something which is as I said, you have some steps there. So there is a watch Kubernetes API for namespace event. User create new namespace inside of the Kubernetes. Yeah. So this is consumer kubectl namespace create, you know, and then NSX is automatically as it is received via API call, listening and creating namespace construct, which is the tenant or let's say edge firewall automatically. Yeah, so there is a new subnet which is automatically, you know, applied for that network construct. Yeah, so there it will create a new edge device firewall with all required gateway setting, a DNS setting, all required things. So it's fully isolated and fully controlled, because you can then set where it can communicate to which another pod, to add a system outside it can communicate with, what kind of security should be applied there. Yeah, so you can inspect traffic, you can inspect guests, you know, you can do some stuff. You can do some stuff to analyze traffic based on rules across the pods, across the platforms, from, you know, virtual machines to Kubernetes, from Kubernetes back to virtual machine via NSX-T implementation. Yeah? Because again, NSX-T could be used for virtual machines, could be used for Kubernetes, could be used for KVM, could be used for NSX-I. Huge. This is really, really integration. Plus, we have implementation now already in off-premise, so you can connect even to the Amazon. Yeah, so we have implementation when NSX-T is watching inside of the IIS, AWS, and you know, you can just do some kind of communication settings, and you can create some SDN overlay network across the on-premise and off-premise. Yeah, so that's quite complete story, and we have also other options when we can use NSX-T. Also, some additional IoT scenarios and a lot of other systems. But generally, this is about the architectural, so Kubernetes virtual machines across the multiple hypervisors, which is attractive, really attractive. So, yeah, well, this is new pod creation. So create watch for API for any pod event, user create pod, API server notify to change and request some IP from namespace. Yeah, so it will just add some IP address, and it will of course update MAC or let's say IRP table. Yeah, so, and of course behind the scenes there is a VLAN structure, but that's the internal structure which is behind the scenes automatically done there on the hypervisor. Yeah, so yeah, and of course we need labels, respectively tags. I mentioned we are using tagging, so that structure which is used in Kubernetes as a label, and inside of the NSX-T we called it tag, but generally it's the same concept. So we are using something which is across architectures, yeah, as a name. So you will name it Frantisek, and it will be there, visible in a Kubernetes, and you can play with that side of the pod structure namespace. But you can also see it as a structure inside of NSX-T. So you can then see, you know, in both systems consistently what you are doing. Yeah. So what part of infrastructure we are playing with. All right. So I would say this is not so important because generally, yeah. Yeah, NSX-T value proposition. So yeah, we are using in this used to be VXLAN, maybe you know, overlay Cisco, VMware, I don't know, some Broadcom or some guys some time ago just created standard, which is VXLAN. Now that solution inside of NSX-T is used. There is a different mechanism, but VXLAN, that's something which is used by Flannel. So Flannel is well known. I mentioned it, which is using overlay for a routing and networking, creation of networking structure for Kubernetes nodes. Because I will repeat it, Kubernetes is expecting that the network will be there, yeah? Somehow created across the nodes. I mean, not inside of the node, but across the nodes. So, and this is the way how you can do it. It's overlay protocol. VXLAN, I think there is supporting maybe more, but this is primarily used by Flannel. Used to be primarily used by NSX-T, also used to be used by other solutions potentially. Now we have different one, yeah, but generally it's tunnel, it's encapsulation, so you will transparently do it across the physical network. So you will not communicate with physical, let's say, routers and structures there. You will talk, you will propagate and create structural routing inside of that solution. So it will be distributed across those nodes. Inside there will be on every node information regarding routing. Yeah? So when there will be demand from pod 1 to pod 1 on node 1, from node 2, so pod 1 on node 2 to pod 1 on node 1, there will be, distributed information across the nodes, where to go. Yeah? Primarily, there is a distributed value key store used for that. Yeah? So ATCD, which is inside of the Kubernetes project, is used also for this kind of distribution of routing information, networking information, and stuff like that. Yeah. So Calico on the other side is not overlay; it's more about routing. So it's a project which is taking about route information. Yeah. So again, this is overlay, Flannel, and this is the solution Calico. And other projects you have to use, you have to create, you have to instantiate, configure, whatever. You have to manage it somehow. Yeah. So you have two things: overlay, one project, Calico, Flannel, and Calico is another project which is taking about routing. So two things. Yeah. Yeah. So BGP, that's standard protocol for dynamic routing, somehow done with this project. And of course, there is a firewall based on standard IP tables, yeah, per node. Yeah, so it's kind of basic stuff there, which is quite, how to say, challenge to manage, yeah, and scale, and monitor, and whatever, troubleshoot, whatever. You can do it somehow. You can do a lot of stuff, but it's a tough thing to manage and to go for a day 2 operations. Yeah, so it's called, okay, when you will join those two, you have Flannel plus Calico, which is called like Canal project or joint venture, or how to call it. Yeah. So then you have also overlay, to nicely spread communication across the physical network, across the nodes, and also that BGP are the routing in one kind of approach, but still you have plugins, two plugins, you have kind of two projects to manage, to troubleshoot, to whatever. Yeah. So what is NSX-T? Value proposition is that NSX-T is implementation which is directly integrated with the hypervisor. Yeah, so there is a performance gain. So it's tuned, optimized, supported for specific hypervisor platforms, ASXI, KVM. So then you have native, if you are using right hardware, networking components, you can have very nice performance if you are going for an enterprise level of deployment. Yeah, if you are just playing, it's not important, but it could be important if you would like to have high performance. Then it's really important that it's integrated with hypervisor. You have complete separation, you have nothing there automatically visible via one central management, which is also graphical. We will see it. You have firewall, micro firewalling or micro segmentation, distributed firewalling across, and you can be fully visible, yeah, fully manageable. So yeah, you can nicely also can see complete map of communication visually. So you have flows there included there inside of that, and you can troubleshoot how packet is flowing from Kubernetes pod to another pod or to another node on a physical network to virtual machine. Yeah, so that's that. All right, so I would say let's go for some hands-on. Maybe I'm just a little bit in attention to show you some how I will go to my okay, one graphic I wanted to show. Yeah, okay. Yeah, so this is just the kind of code kubectl create namespace when there is automatically creating behind the scenes edge, yeah, which is this one, specifically for namespace team A with logical switch, which is some IP address space or subnet 24. Yeah, potentially with load balancer automatically to load balance with some portion of nodes for load balancing. Yeah, automatically created or destroyed, of course. So if you are creating namespace pods, behind the scenes, all this stuff is automatically created, destroyed. All policies are created, applied, and backward destroyed. So you are ready for a real environment. You have, you know, something you can provide to security guys that we are ready to deploy it for a real environment, because they can understand. Yeah, networking guys, they will understand this construct. They will understand that BGP is there. They will understand there is overlay. Hopefully they will understand there is overlay, because networking guys tend to be a little bit defensive and feel offended by the new approaches of software-defined networking sometimes, because they are very rigid. Yeah, so some of them, most of them. So even there is problem, but generally they understand that there is some kind of edge device, which is a router, which is a firewall, which is potentially load balancer, and they understand that this construct is something they understand because there are basic networking concepts there implemented. And they can visually see that that's virtual machine and it's some CLI there. They can check CLI of that edge. They can even see some GUI, and via GUI they can control what's going on there. So that's really power of this, that you can provide this to regular, semi-regular networking security guy in a company of customer. Yeah, I would say it's not that ideal, because we still have hardcore networking guys. Yeah, but if you would like to deploy Kubernetes, it would be really, really good to go for a software-defined networking. There are a lot of benefits to use software-defined networking, because it's highly automated. That's what we need, of course, for Kubernetes. Of course, we need automated. So this is the joint venture where we should connect hardcore all these CCNI, CCNA, Cisco specialists from their rabbit hole to guys from application development, Kubernetes ninjas, to sit on the one table and to discuss that they can see this one, and you can see, of course, this one as a guy consuming Kubernetes. Yeah, because you don't want to take care about networking. You don't care about networking, of course. You would like to play with Kubernetes, to deploy your application and to test application, multiple versions and stuff like that. So all this should be there somewhere. Yeah, and it is with NSX-T, it's like that. So yeah, so there is some running state of image NGX on team A, yeah, which is now covered by the security appliance, taking care about rules, inspection, separation, of course, application of policy there, to have load balanced, yeah, or access across pods or namespaces, or policy to not have communication across the namespaces. And you can, this is the power you can control. Then you have full control. You have visibility, yeah. So then you can have a load balancing across the multiple pods. Yeah. So yeah, this is the construct multi-node edge cluster. So you can in the large deployment you can have a lot of those edges, a lot of pods, a lot of edges. So maybe you will need dedicated set of physical nodes for that. Yeah, and plus VMware is playing now in the field of physical edges, but that's crazy. Let's forget it. But maybe there is a time that VMware as a hypervisor company will start to be a semi-physical company. So we have first version of NSX when we have kind of binary. You can deploy on Dell Edge server, for example, and have physical edge firewall router, which is, how to call it, white box Dell server or how is it called? Super micro. When you will have a software edge, but on a bare metal, and then with high performance router firewall. But now, forget it now. This is each of them is virtual machine, of course. Yeah. East-west routing, yeah, scalable, embedded in hypervisor. So all those machines are, routing, switching, all is optimized because those informations about routing are not traversing physical routers. All those communications and routing informations are handled by NSX-T controller, which is not here, by the way, but behind the scenes we have special so-called controllers, and they are taking care about complete routing. So we are not going for a routing information somewhere down there and looking for some routing tables somewhere to have some decision from physical network device. All that stuff is optimized. So there are no multi-hops on the network. Yeah, because if you have multiple levels of switches, then you have to traverse all of those switches to gateway when you have communications across the L3 segments. And you are traversing network across the multiple hops for each packet when you are traversing L3 to other segment, yeah, which is potentially somewhere on the network, on some node, somewhere, on some hypervisor. If you are going via, non-SDN solution, you are traversing across some kind of multi-hop across the multiple devices on the network potentially, and you have overhead. Yeah? So this is also the factor that with this solution you have SDN optimized. So if you have two pods running on the same hypervisor, then of course you are not traversing multiple hops. You are communicating directly. Yeah. So there is a lot of optimization with software-defined networking solution. All right. So yeah, ATCD as a solution for exchanging information for some solutions of networking. There is a ATCD used. Yeah. So okay. I would not go into those slides. Let's go for the lab, or let's have a break, and then we can make a choice. But I will just go for a Katacoda first, or if you would like. Oh, this is connectivity, perfect. So we are done. So then we are done, guys, because I don't have connectivity. Maybe I will switch to my iPhone connectivity because this is not usable. Or okay, let's
maybe disconnect and connect. That helps me 3 times already.
Okay, so we are done then. It's not going to be workshop. Come on, let's ping. Okay, so definitely I have. Vystoupil, nastoupil. Jak hovorí Zimmerman? Nastoupil, vystoupil. OK, takže so this should be open for everyone. And we have a lot of stuff there. So I think this could be interesting. This could be interesting. Or this is nice and white. If you are interested in HOL, VMware NSX-T solution, there are nice labs. So you have to register and you have free access for 30 or 60 days now. It used to be 30 days or 30 hours of active time. Yeah. So, but I heard that it's more now. So, okay, you can register with another Gmail then, as a hint, or you can pay to VMware for some kind of access for longer time. So Kubernetes. And there is 8026, but there is newer, more up to date. I hope it's public because I have maybe a little bit different access, but this should be there. Integrated Kubernetes with NSX-T. Yeah, so this is. There are pure Kubernetes. I think. Pure Kubernetes, yeah, this is it. I think this is pure Kubernetes with NSX-T, because there is also pivotal kind of complete solution. This is pure networking with Kubernetes, pure networking stack of PKS. If you would like to play with complete infrastructure, which is Bosch, as I said, taking care about the health of Kubernetes cluster, there are labs for that. Every each is for 3 hours, 2 hours, I don't know. So, I have some account. By the way, I just till this moment I didn't get the idea behind this. If they would like to have paid access then later, I don't know. All right, sign up, login. Okay. So then it should, hold maybe some information what you have done inside of training part for Kubernetes. Yeah, so there are load balancing, basic stuff there, cluster, IP, some multiple kind of approaches there inside of Kubernetes. There is also overlay solution, networking solution as a scenario there. Why is not going? Start scenario, okay. Yeah, so then you can play with commands. You can apply those commands, and yeah. So there are definitions for creation of services when there is some kind of Docker HTTPS server deployed, running, service created with IP accessible, and checking whether it is working or not then. Yeah, so you can see what you are running, where the services are running. So there is another type, port-based access. You can see endpoints, so pods or nodes when they are running as an endpoint. And this was processed by one of those. Yeah. So if you will then see that it's one time it's going from one node, another time it's going from another node. Yeah. So if you just refresh again and again and again, it's going from another node. So it's like access which is spread across multiple. So there is another way how you can expose with port-based. And again, handled by multiple pods. Yeah, so this is one. And there are other. Yeah, you can launch fresh new cluster. You can deploy guestboot application, and plus, as I said, yeah, you can see Helm for deployment of application, and I think there was Weave network as an overlay solution there. Yeah, so Weave. Yeah, so this is like there is a Calico and Flannel. So there is also another solution which is supported or in open source Kubernetes IO as provided as a CNI network interface solution for overlay Weaveworks. Yeah, so this is also something we can go through. But on the other side, what I like, which is more deep into the infrastructure, and you can see also infrastructure as a service there. You can see the network controller, you can see management of network, and that's NSX-T solution. Yeah, so this is real environment. I mean real. You can interact, and let's hope it's interactive for real because of network. But looks like, but maybe we have to switch a little bit this one. And yeah, well, there is, of course, there is access to NSX controller, NSX CLI, and there is also access to Kubernetes, of course. There is access for a NSX manager. And if you would like to, of course, it's up on you, but there are multiple modules, and you can start with any module you would like. So there is introduction, there is Kubernetes namespaces, creation process, how it works with NSX-T, how you can see structures in NSX-T management. Yeah, so for example, ingress rules, security, I don't know, we can try load balancing, or you can use microsegmentation potentially as a security. But okay, let's go for a module 2. Yeah, so you can see structure inside of hypervisor. Creating posts, okay. Yeah, so you can see that there is the description of what's going on there, and I would check where is the first starting point. What is components module 1? Let's take a look. Oper putty. Okay, let's go for a Kubernetes Master. So maybe we can start here. Yeah. So it's putty, and we should go for a, I think, Kubernetes Master. There is a topology, of course, information about all this. Yeah, so I really hope there is some kind of topology. Somewhere is, yeah, of course, but yeah. So here you are accessing virtual machines. From virtual machines, you are accessing applications you will deploy. There is one application you will deploy in Kubernetes, and you will access it via routing information in the NSX-T via the edge device. Yeah. So, but there is also nice information. I think lab overview. Okay. Yeah, similar. So this is Kubernetes cluster, and this is a node. It's not so nice. There are nice, maybe nicer descriptions over there. So, yeah. Yeah. So you can really go inside and check for basic infrastructures, what's there deployed, and you are going to, yeah. Yeah, so there is 2 nodes, Kubernetes 1 master, and yeah. Description of that. Yeah, Yeah, get namespaces. Okay, so kubectl get. Yeah, so that's default implementation on each Kubernetes. Yeah, and this is access to NS6 on the other side. So yeah, where you have routing information, where you are going to add nodes routing for routing information, so some kind of controllers, and there will be also switching information and stuff like that. So yeah, this is load. Yeah, you're going to switching, and yeah, then there is some requirement. I think I switched to different part of the lab, but you are creating some stuff, and you should see there some structures. Yeah. So yeah, of course, firewall. Yeah, so you can see a rule set which is applied then for each segment. Yeah. So of course there is also information about Fabric, which is nodes, which is hypervisor node. Yeah, so you can see here is some kind of KVM, but there could be also, of course, ASXi hypervisor there. Yeah, so yeah, well, I would say location, click and drag, manual accessing online. Okay, this is basic. You can just, this is just the information how you interact. Yeah. This is information about Kubernetes, what is namespace, what is pod, what is controller service, DNS, ingress, network policies, yeah, lab topology, and here is a real lab. Yeah, so yeah, that's something we can go for. Yeah, just a few bunch of informations like password and stuff like that here. Okay. Yeah, here's then application also deployed there. So you should deploy application and see structures inside of the NSX-T and test it. Yeah, so I don't know if you are okay to start it, register for it, or for this lab. As I said, it's free, so you can do it. And important thing is that you can extend default time. Yeah, there is a time of 1 hour 30 minutes, and you can extend it, yeah, 8 times. Yeah, so 9 hours for that lab. Of course, you can then, maybe good idea is to go for a one part, module 1, for example, or module 2, because module 1 is just the introduction. But just to focus on one particular part, which takes 45 minutes. So, and if you will finish, mostly in those labs, you can just go for another part separately. So you will finish module 2, just one module, and then you can go for another next time. Yeah. So, and I think there is information about this. So when I will go for a fourth, which is security, microsegmentation, there should be procedure. Yeah, login to master. This is it. Yeah. So run the module in its script, and the script will prepare you. So it's not required for you to go through all 3 hours, 2 hours of training to be on the fourth module. You will just instate the module 4 init script, and it will prepare all that stuff. So if I will try it, so I'm on a Kubernetes Master, and there should be module 4 init. Yeah, so it's configuring for module 4 completely. Yeah, script created namespace NSX-Ujo. It's cool. It's Slovak languages. What's the Ujo? In English. Uncle? Yeah. I don't know if it was intent. So there is a context set, there is a replication controller, service there created, all the stuff. Yeah. And of course you can also cut and paste, copy paste. Yeah, that's also doable. So guys, some of you are leaving, so I don't know, hopefully I brought you something. Yeah?
I will look at it, but I have no
yeah.
memory anymore.
So maybe I will provide a comment, and I will make a photo. Stay here. Yeah, yeah. Because I forget this each time, and then I have no proof that it was like successful. So sorry guys, but I would like to have a first ever photo of my meetup. Sing hallelujah. 3, 2, 1, cheese. Perfect, guys. So I will provide a feedback form, yeah, on a meetup. So please provide some feedback as last time I provided also. So I don't know if some of you would like to provide some content next time, or some hands-on, some pipeline, some other storage-related stuff, something, Docker, pure Docker, first steps, or you are more, educated in some parts. You can provide something to others. Yeah, so that's something I would like to see from someone, to challenge himself, herself, to go for it. Because myself, I'm more infrastructure guy, because I'm from VMware. And myself, I'm trying to challenge myself to do this. But that's why I'm trying to do this for 5th time now. So it would be nice to see someone, and we had examples from last meetup. One guy delivered session for networking. We had guy for CI/CD. Yeah, so we had guy which deployed already microservices for financial institution. So doing stuff, and he was Java, old-fashioned Java guy for a decade in bank, biggest bank in Slovakia, and he switched after all because DevOps there is tough. So that's inspiration. Yeah. Okay, cool, guys. Thank you very much. See you. Yeah, so, yeah, guys. Yeah, ciao, ahoj. Ciao, nazdar.
It looks like the older one's the only one available, not the 1.9.
So 926 is not there?
Yeah, I can see
18.
I can see 18.
1826. So I would say it should be very, very similar. To be proud, I don't know what's different there. But generally, there is a concept which I described in first part, theoretical part. So this is just the reality there, how it works when you instate it, new namespace and.
So one interesting thing is also to see just the network visualization, because that was actually sort of the part that I was curious, just to see, you mentioned that.
Oh, you mean complete setup of the lab?
Yeah.
Yeah, okay, I would like to see it also. I have to look for that. I will check. By the way, there is one hint which could be useful, and it's something like HOL docs, when you can find complete lab manual as a PDF, which could be useful sometime for documentation, which could be useful for just to have documents on hand to use for procedure you need to have on your hands. Sometimes you need, yeah. So then it's not required for you to go into the lab, but you have PDF, yeah, and you can use it when you need it somewhere to replicate it in Kubernetes deployment. So then you can search for Kubernetes, and there you can see Kubernetes getting started. Yeah, so that's another interesting, by the way, another interesting lab. So pure Kubernetes getting started. Yeah? But this is VMware NSX-T, so that's 8026. Yeah? That's the lab you can see. I have special access, so I have newer, more up-to-date version, but this is what you can see in lab environment. NSX-T with Kubernetes, and then there is PDF version, yeah? And it will generate complete PDF lab guide, which is downloadable, useful. Yeah, that's really cool because, and another tip for you is that there is a name of guy doing that stuff. Yeah, that's quite useful also. You can look for that guy on LinkedIn, Twitter, and you can just ask him why, where, what, with whatever. So it's like some US guy. I have, some captain of lab, which is taking care about that complete lab. So yeah, I'm just looking for a setup of the lab picture. NSX-T topology. Okay, compute KVM, compute as its host. So I would connect to that one to be sure that I see what you can see. So 8026. So again, for you, there could be also interesting lab which is pure Kubernetes. So okay, I will just start this one. A lot of theory, you can see. So it's completely described what's fabric node, what's external logical router, logical switch, blah, blah, blah. So I would say lab layout from a perspective of Kubernetes here. Yeah, so you can see view of vCenter, that this is VMware when you have two hypervisors when Kubernetes Master, node 1 and node 2 is running. Yeah, and you have management cluster where edges, controllers, NSX manager are running. Yeah, so let's say this is like for pure, let's say pure Kubernetes runtime. So two physical hosts are, let's say, dedicated for real workload. Yeah, so we have here Kubernetes Master and Node 1 and Node 2 as a workers. Of course, this is manual way of deployment of Kubernetes. So you are creating Kubernetes Master with nodes manually. So, you know, some guideline how to deploy for virtual machine, pure, you know, some SUSE distribution or some, you know, some setting for Kubernetes Master and nodes. Another option, how to deploy Kubernetes cluster is PKS, but that's another topic. There are some other components like Bosch, so Borg on steroids. But this is pure Kubernetes, vanilla Kubernetes installation in virtual machines, and this is NSX manager with controller, which is taking care about routing, and plus edges. So edges are then created automatically when a consumer in Kubernetes is creating namespace. So you have to, you know, you can see into the architecture now. Yeah. So this is physical server where you have hypervisors. Those are virtual machines running on physical servers, hypervisors, where 3 of them are Kubernetes nodes. Yeah. And you are providing Kubernetes interface for kubectl via SSH, as I showed, for consumers. Yeah. So consumer then is playing with namespaces. Of course, you need to configure first, before you are going to provide Kubernetes to consumers, you will configure NSX. So NSX will be deployed. Yeah, as machines, you will prepare also those physical nodes with hypervisor for that kind of deployment when overlay is configured. And then you will point that NSX manager into the Kubernetes. Yeah, so then Kubernetes is API calls from Kubernetes masters are listened by NSX manager, and when there is inside of Kubernetes, you know, inside of the machines there's Kubernetes, and when there is the call for namespace, NSX manager is instigating or creating edge for that particular namespace. So you will then see new edges created per namespace. And you will see that there is a setting, and inside of the NSX management, you will see port, you will see security applied, and all that stuff. Yeah, so this is Kubernetes, log inside of the Kubernetes. You will see nodes. Yeah, you will see their DNS service as a container, pod running. Okay, you are playing with that, you are restarting service, you have API servers, classic standard API server controller, proxy, and namespace. Yeah, this is the fundamental concept. So now you are going to create namespace inside of the Kubernetes. Yeah, Kubernetes Master, get NS namespaces. Yeah, so, and you will see inside that there are constructs. Inside of the NSX manager, you will see default kube public, kube system namespaces, which are default in Kubernetes. They have automatically structured there as a switches, as a logical switches connections. Yeah, so there is a logical switch which you can see is overlaid. So then communication across the pods, across all of those structures inside of Kubernetes, which are visible in NSX-T, are communicating across overlay. So overlay means hypervisor is communicating with other hypervisor. When you have nodes of Kubernetes across, is communicating via the overlay. Overlay means that you have classic standard Ethernet communication packet or frame, let's say, no, not packet. Packet is IP, L3, L4, TCP, IP packet, so L3. But on a lower level, data link, network layer, L2, you have Ethernet frame, or which is the default 1500. For overlay, you need some additional metadata, let's say. So to work with overlay on physical network, which is here, traffic type, for all those structures there, you need to set something like, I think it's 1,500, under the 1,000. It generally recommended is to set minimum 1,600. So you should, for those specific ports on network, on a switch, physical switch, you need to set 1,600 for Ethernet frame. That's it. That's everything you need. From that moment, you can run overlay, software-defined networking overlay traffic, and from that moment you have visibility and you completely control traffic, segmentation, security, all that stuff inside of the hypervisor. That's the magic. Yeah. Of course, overlay could be used not only for hypervisors, but in a hypervisor we need it, or it's nice to have in hypervisor, because then you have a lot of freedom to play with security and segmentation, and you are not dependent on physical hardware, gateway, router, firewall. So we are replacing physical firewall partly. Most part of firewalling is going into this SDN. Most routing information, every route decision is then made inside of the solution, NSX-T solution, not on the physical router device. All routing information across nodes of Kubernetes, across virtual machines, because we have also virtual machines there. Yeah, so in NSX-T you will have a Kubernetes structures, but you have also virtual machines in one solution. That's that magic.
Right. So just drilling down into these virtual switches, or you mentioned that you could visualize the data flows. So if I authorize particular communications between two namespaces, so what would that sort of visualization?
Yeah, you will see inside, and I will try to show you here somewhere. You will see ports. So you will see that port, that pod, whatever, is here and I can see port on the virtual switch. So then you can visualize, you can block, you can apply security policy, and you can allow this port to communicate with other port on virtual switch via overlay. So that port or that object could be here on this hypervisor, could be on this hypervisor, it could be virtual machine on different platform, KVM, or VM on NSX-T, or Kubernetes on KVM, or Kubernetes on running on NSX-T.
Okay, and then how does it relate to the network policies that I defined in my YAML class? So is it trying to reflect that, or is this in addition to the network policy?
Yeah, you can simply run the policy and apply. Via that policy, you can also apply microsegmentation, for example, and construct security constructs and mechanisms in NSX-T. So the same construct will instate or call other security stuff which is inside of NSX-T. Yeah. So perfect. Thanks. So I will try to look for. Yeah, you can see like ports. Yeah, specific ports. This is routing, but there should be somewhere switching and specific ports. Yeah, by the way, this is a guy which is heavily involved in NSX-T, Yves Foser. So you can see on GitHub, there is a demo application for NSX-T integration you can use. Switching, and yeah, this is it, ports. Yeah, so you can see application deployed as a namespace, and it created logical switch. And logical switch has ports, and you should see that there is a correlation of port, which has tag, which is relating to the label inside of the Kubernetes.
Okay, sorry. So the UO there, that's the namespace, or is that the
namespace? That's namespace. This is namespace, where you have application inside deployed multi-layer, when there is a DB, when there is a applications layer, and when there is a front end. But it's in one namespace. Of course, you can do it across the main namespaces, but yeah. So, this is something you can see there. There are logical ports for every each, potentially for every each pod. Yeah, so there is a NCP pod. You can identify pod inside of the security solution overlay Microsoft software defined. Yeah, there is an app project. It's called project, but it's name of the application. So in a YAML, or when you are running service or whatever, you have a project name of that structure. So, and we can see it's in the implementation of NS6, it's called project. Yeah, I don't know why. And NCP is plugin. That's Kubernetes called it NIC, CNI. But VMware implementation name is NCP plugin. Don't ask me why, but it's project. Yeah, so project is the name. Inside of Kubernetes name, there is a project name. Yeah? So cluster, when it's running on what cluster? Or Kubernetes cluster. Yeah, so there is a pod name. Yeah, you can see application name. Yeah, so and here you can see binding, MAC address, IP address. Perfect. This is what security specialists need.
Okay, yeah, this is like the type of question is very hit up.
So yeah, so there is a lot of things you can do then, and maybe it's tough to completely uncover all benefits, because just when you join those teams, then you can see. Because one will ask for networking stuff, one is talking totally different language from the Kubernetes stuff, and when they are starting talking about some platform when they can talk around one table, you know, then this is useful. Then maybe some values are uncovered, because one can see it from his side on one solution, on the same solution, like other stuff, other part is looking. Yeah, and that's NSX or potentially some other platforms, but this is something which is quite consumable. Yeah, so routing completely, complete, visibility into the map of route table, the setting or configuration for BGP, dynamic routing, which is, GUI-like visible. So, of course, in command line, but yeah, this is the application access. Yeah, this is it. This is really interesting. So now we can see policies, for example, or definitions tagging there, and based on that, we can apply security definition for traffic inspection, for example. Yeah, so we can apply then some kind of policy of SDN. So when there will be detected strange behavior, or DLP, data loss prevention, so there will be some, let's say, suspicious activity. So then it will automatically isolate completely that construct, so namespace, which is huge. Yeah? Of course, you can provide it then to some third party to just do inspection and provide information to SDN that, okay, this is strange because it's against, when we checked against some I don't know, database of attacks, we can declare that this is really strange behavior and block it, yeah? And it will automatically block or quarantine that namespace. So this is really something which is there out of the box, applied behind the scenes, visible and controlled, monitored by security guys in company. And they can define rules. So in this cluster, Kubernetes cluster, whenever they will be creating namespace, there should be this set of rules, firewall rules, inspection rules, just to be sure that in case there is problem, it will be isolated automatically, which is huge because they need to control. If you are going with Kubernetes into the real production just like that, it will be, it's the security showstopper. Yeah, so they will stop you because especially in bank, financial sector, it's no go to just start something somewhere. Yeah, you have to use some proper tool to declare it's secured, and you have control, real control. And this is tool for the control. So. Yeah, so there is kind of relation across the security group and TAC, which can be applied there. Yeah, so firewall, you can play with firewall. So then you can play with multi-tier application, and you will just try to block and allow firewall rules. Yeah, so you will block it here, and you will instantly, the web front end will show just a part of that web page. Another part of page is database and is disabled or blocked by firewall. So you will see that, okay, no, not accessible. So web is accessible, but not database, yeah, or some connections across pods. Here is a scanning of ports. Okay. Yeah. So. Yeah, it should be refreshed when you are disconnected or you are idle for some time. Okay, guys. So, would you like to go with it now or maybe later?
No,
Yeah, it's too long.
I have a question like, I'm totally new to the Kubernetes, and
Uh-huh.
Is there like, the introduction is like suitable for me?
Yeah, I would say for you, maybe Katacoda, definitely. Definitely. It's just like no registration or something, you know, you can see it's instant and immediately consumable. So I would suggest definitely to go with this Kubernetes introduction, and you have, you know, launch a single node cluster, multi-node cluster, deploy containers on Kubernetes, you know. So I would say this is really nice, you know. So scenario start. Yeah. By the way, yeah, this is a Minikube. Minikube is something you can install on your laptop instantly. It's downloadable. I had a little bit problem with certificates. It was 3-4 months ago I installed Kubernetes, which is installable on laptop, simply like that. Yeah. So you will search for Minikube, and it's one virtual machine when you have Kubernetes cluster. So that's the simplest way how to run and play with Kubernetes, to download Minikube and run it on your laptop. On Mac, I had a little bit problem because it's mapping to hypervisor, or yeah, I used VMware virtualization software. Yeah. So it was a little bit something there. I don't know if it was related to VMware virtualization software on my laptop, but there was workaround. I had to search a little bit on communities. But I don't know. Maybe on Microsoft, when you will install Minikube, is it also for Microsoft? I would say yeah. I don't know. I think so. So it should work somehow. It should use virtualization VT technology of Intel CPU. There is support for virtualization. So somehow it will just suddenly run Kubernetes on laptop. So then you will see something like this, but here is instant, even better. It's just somewhere in the cloud. Yeah. So it's there. You have console in few seconds, and you are playing with Kubernetes. Yeah, so there is some, I don't know, version. Minikube has different versioning apart of Kubernetes. Yeah, so it's, I don't know, something. Yeah, newer version of Minikube available. All right, but yeah, local 110, which is quite, I think.
That's the second. It was 111.
111 is, yeah. So, but something like stable or whatever. I don't know why. Yeah. So it's running now, yeah, and you have some basic information that you can access it on IP address. You can see that there is one node. It's one node cluster Kubernetes, so it's like master and running worker in one. So master is also running pods. Yeah. So then you have first deployment running Docker HTTPS server in a pod. Yeah. So you have first pod running in a Kubernetes magically, without installing anything anywhere. Yeah. So this is nice, and then you are exposing it via some kind of technique, port redirection by default, let's say. So you are redirecting pod IP communicate. As I showed before, there is IP of pod, but then you have IP of host. So you need to expose that somehow out to the physical world on one node. Yeah. Then there is a problem of multiple nodes, and they're starting to be a little bit problematic. You need some kind of technique, overlay, Calico or Canal and Flannel. But this is simple, so this is not problem. Here you don't need anything like Calico, Flannel, NSX-T. This is very simple one, inside of one host, and there is one pod. So if you will repeat this, you will still have request persist by the particular pod. Yeah. So if you will go to history, get pods, it was handled. Request web curl request against the web server, HTTP, because it was some kind of web server deployed as a Docker image, and it was a response from, even I repeat it, still it was handled by this pod, and this pod has a running Docker HTTP, some kind of web server, which has something inside, some web page potentially or something like that. Yeah, and then there is a there was a dashboard, visual dashboard to see what's going on there. Okay. Yeah, so it should, maybe it was too fast. Yeah, probably. So then there is exposed visual information about your cluster. Dashboard is standard visualization tool for Kubernetes, which is kind of like pod running, showing you visual information of your Kubernetes cluster. Okay, I will try.
But for example, on the other side, the PDF version you showed us.
That's different. This is Katacoda.
Yeah, I know. But there was, as you started up, there was switcher and router automatically configured, but there is a possibility to configure and test. For example, you said the firewall, you can check configuration or just.
Yeah, there is also firewall part.
Yeah.
In the NSX-T, NSX-T is taking care about routing, switching, firewalling, load balancing, and also VPNing. So we can also provide VPN connections across the remote sites, stretch size, whatever. And that's huge because you are taking a lot of stuff from physical network into the software network, software-defined network. So guys like F5, Cisco, Juniper could cry a bit if there would be a lot of SDN like NSX. Those guys would cry. If they would go with SDN as Juniper, maybe VMware will cry. If you will choose open source, every vendor will cry. Because you will choose something like Canal and you will do it somehow on your fingerprints, somehow. But if you would like to go into production, you will pay for something like this, and you will have nice way of doing Kubernetes and play security stuff and stuff like, you know. Okay, now it's working. So now it's working. So now you can have something which is, you can do it, of course, every time manually on your laptop. You can create it on your VMware or KVM, on physical. But this is nice because, you know, just like this, and you have something you can explore. Perfect. Yep. Thanks. Take care. Cheers. OK, let's finish. To sme už Slováci iba, ne? Dobre. Tak skúsim pozrieť, či mi to nahrávalo. 2 hodiny 26, 11 giga vecí uložených.